Finally, someone has clearly explained carbon nanotubes. FCCVD is a continuous gas phase process for the production of single-walled carbon nanotubes. It overcomes the limitations of conventional CVD processes and enables efficient, continuous, and large-scale production of SWCNTs. Traditional processes rely on solid substrates, with the catalyst fixed on the substrate surface. Therefore, growth is discontinuous, production capacity is limited, product separation is complex, material loss is high, product purity is relatively low, and the overall process is cumbersome, inefficient. In contrast, Boyee's FCCVD technology uses suspended nanoscale metal droplets as catalyst particle rather than a solid substrate. SWCNTs are generated directly in the gas phase, fundamentally eliminating the limitation associated with substrate-based growth and making the process more suitable for continuous industrial production. The system adopts a four-step continuous growth process. Precise feeding. Carbon source and catalyst precursors are uniformly introduced into a high-temperature reactor. Catalyst formation. In the high-temperature zone, precursors decompose to form suspended nanoscale catalyst particles, which remain uniformly distributed in the gas stream. Directed growth. The carbon source decomposes on the catalyst surface, enabling continuous SWCNT growth along the gas flow direction. Continuous collection. Products are carried out with the gas stream and continuously collected via a rotating mechanism, enabling uninterrupted production. Compared with traditional CVD processes, Boyee's FCCVD technology provides significant advantages in catalyst configuration, production mode, scalability, and product consistency, making it more suitable for industrial-scale SWCNT producing. Boyee's FCCVD SWCNT growth equipment breaks substrate constraints, enables continuous mass production, precise control, and large-scale manufacture of high-purity SWCNTs.